Thank you, everyone, and thank you for coming today. So over the next 20 minutes or so, I'm going to share with you what visibility can do for cybersecurity in general, focusing on cloud. So this is this is the topic that I would like to discuss today. So we're going to spend a little bit, couple of minutes talking about the security challenges, then what is visibility and deep observability. Then we're going to talk a little bit. I'm going to introduce a very exciting new technology aimed specifically at monitoring encrypted traffic into a cloud. And also, why is it important to monitor lateral movements, or the so-called east-west visibility, east-west movements. So let's look into it. So cloud security, it's a major concern for everyone. There's a lot of companies that made the news being compromised. But also, one of the issues that has been quite pervasive over the last couple of years is that it's not a single cloud anymore. A lot of organizations, or most of the organizations, 87%, are using multi-cloud environments, meaning it's no longer one cloud provider. They're using multiple cloud providers. Also, most of the infrastructure does not sit into public cloud. There's a cross between on-premises and public cloud, giving the birth of so-called hybrid cloud environment. Now, when you look into hybrid cloud environment, there's a lot of visibility gaps and security gaps that becomes quite apparent. So depending on how your cloud is implemented, you may run into a lot of blind spots. One of the questions that you need to ask yourselves, are you sure that you have complete visibility into what's going on into the cloud, either for security or for operational purposes? Increasing cost. If you have gone through migration from on-premises to cloud, probably you have realized that all of the network services that you took for granted into your on-premises data centers, in public cloud, most of them are not free or not available. You have to pay for them, and you still cannot get the functionality even today to what you have into on-premises. In flexibility, this actually creates a lot of rigid structures that are difficult to resolve. Regulatory compliance, and even application and infrastructure performance issues. So that's why it becomes very difficult to monitor east-west traffic within a private cloud and hybrid cloud. In today's environment, most of the security solutions are implemented into monitoring north-south. The premises for this is that everybody within my network is a trusted individual, right? So as long as I monitor north-south or my parameter, I'm more or less okay. And if I want to do something within my network, I will use segmentations or macro segmentations. That is pretty much the pervasive wisdom today, and creates a lot of challenges as well. So what are the hybrid visibility challenges? So one of the challenges that we have is acquiring traffic. You have many points of acquisitions. You have to consider the physical. You have to consider virtual, containers, cloud-native traffic, tunneling traffic, or traffic that goes between different points within your public or private cloud. Another challenge that you have to consider is distribution. You have to distribute packets, filters. You have to encrypt the traffic. Maybe you want to generate metadata for ease of usage within the tool, so in-depth analysis. And also, you need to be able to orchestrate and automate it. So, and how can we accomplish this? Gigamon is one of the companies that do this thing really, really well. We work with any cloud, either private or public, any environment. We work with any type of devices. We can acquire the traffic from many different sources, whether it's going to be IoT network, even mobile networks, we have no limitations in that area. We also optimize the traffic. Our optimization technology can save, on average, 50% of the traffic. However, usually in some of the cases, we can deliver up to 70 or 80% traffic reductions. We also provide a lot of intelligence. When it comes to metadata attribute generations for analysis into things like port spoofing, or if you want to see what are the applications that are going across the networks, we can provide this intelligence as well. And of course, we have a unified way to manage all these wonderful solutions. So let's have a look at the cloud. So cloud, you have a platform, and some of it is on premises, some of it is in your public cloud, whether it's going to be Azure, Google, or any other provider for that matter. So of course you have the applications that some of them sit either on your premises or on a cloud. But one thing that you need to do, you need to be able to manage those applications, either for security, for monitoring, observability, or anything that goes within the network. It is important because even before pandemic, but the pandemic, the COVID-19 pandemic, made this issue even more pervasive. 5-6 years ago, most of the organizations, they have their digital operations, but they were kind of like a side gig. Now, today, everything is digital. It runs either on cloud or somewhere in a data center that sits within your premises. If your digital services are down, chances are your business is down as well. So you have to be able to monitor it, you have to be able to operate it, you have to be able to secure it, and you need to know what applications are doing. We had a case a couple of months ago where an application very similar to this one, some of the application was in the clouds, database was all over the place, some of it was in the on premises, some of it was actually in another cloud, and the front page wouldn't load. Now, when you have, even it's difficult to troubleshoot it in one data center. Imagine when you have to go into different environments that not even managed by the same entity. So long story short, what happened is that they had an advertisement plugin that took too long to load. And the way the front loading page was built, load advertisement first, and then everything else. Now, what they forgot to realize is that, well, sometimes those plugins, they take a long time to log in, and if you don't bypass them, nothing logs in. Took them about, I think that several hours to troubleshoot it, and at that time the web page was down, until they used one of the metadata attributes sources that was generated by Gigamon to point the specific loading time for all of the traffic that was coming through that web page, and they pinpointed to that plugin that actually later disabled and everything was working. Now, the tools themselves, they do not operate in vacuum. They need some information, or the so-called telemetry. And so there are two types of telemetry. One of them comes from network packets. The other one comes from log files. Now, the issues with log files is that they can't be changed. This is what hackers do. One of the first things they do once they compromise you is to hide their tracks. How they do that? They change the log files. And if some of you here is in cyber intelligence or compromise recovery investigations, probably one of the, like when you investigate a possible compromisations, one of the indicators that you're looking for is, did somebody change the log files? Or did somebody create a specific user for that purpose? That is usually where you start to look at it. It's not so hard to do, and that's what hackers do. However, you cannot change the network. It is impossible to modify every single packet into the network. And that is actually the way you should be looking for when it comes to cybersecurity threats and analysis. While the logs and traces and events provide a very valuable information in terms of incidents recovery, forensic investigation, etc., one thing what you need to consider is that they can't be modified. However, the network itself is a very powerful source of truth that cannot be changed. And this is the same thing in Zero Trust as well. If you have been going through Zero Trust projects and Zero Trust initiatives, one of the key tenets of Zero Trust is visibility into network traffic. For that very purpose, you cannot change network packets. Not all of them. Eventually going to slip. However, you can change logs, and that's what bad guys do. Now, and this is what deep observability concept delivers. It brings network and telemetry together to deliver a very powerful source of truth that delivers, that actually enables security, enables application monitoring, enables network performance monitoring, anything that happens on your network, anything that happens in your hybrid cloud environment, either for security purposes, network management purposes, or application management purposes. That's what the purpose of deep observability is. Now, and of course, as I mentioned earlier, we can do it across any environment, any cloud, any device, any network. We have Gigamon actually work with more than 200 tool partners, and we work on application level, network level, and intelligence level as well. Now, let's have a look what's happened when organizations adopt encryption. So encryption is very good, and has been one of the main mechanisms to secure data. However, what happened is that encryption limits visibility, which means that your security tools would not be able to procure or would not be able to process encrypted traffic. Now, while this is good that you would protect your data, more than, I think that 70 or 80% of the attacks nowadays, they actually go over encrypted channels, which means that your security tools would be blind as well. And what we have done, we just announced it about a month ago, is that Gigamon has managed to actually decrypt encrypted traffic within the cloud. So if you have tried to monitor encrypted traffic within the cloud, you would know that it's very, especially public cloud. I'm not talking about private cloud. Private cloud is a little bit easier. But in public cloud, visibility into encrypted traffic is a very difficult thing to do. You may be able to do it in your parameter firewalls at great cost because encryption is very expensive. Decryption is very expensive in terms of CPU cycles. However, within your cloud environment itself, lateral movement, it is very difficult to do it. It's almost impossible until Gigamon actually managed to do it. So the way we do it, it's a very simple concept. At one point, the traffic is clear text, right? So when it comes from the application, before it goes into the network, the traffic needs to get encrypted. And what we do, we use actually as eBPF technology to capture the traffic before it gets encrypted or after it's decrypted. It's a very simple concept. We use eBPF. eBPF stands for Extended Berkeley Packet Filter. It is a Linux program, by the way, developed specifically with the purpose of writing code to execute on the kernel level without modifying the kernel. With this breakthrough in place right now, we can encrypt and decrypt without actually changing anything within the systems, and we deliver visibility into encrypted traffic in the cloud. Now, okay, it works on a single node. It works on a multi-node as well. We're capable to monitor east-west visibility encrypted traffic across your public clouds, either within a single node or multi-node. Any type of application, any type of cloud actually would work. If you're a Gigamon customer and you run the latest Gigamon software, you already have it. It is already there. Now, and coming up on my last couple of minutes of the presentations, I want to bring this thing. And this is the latest, this is the largest data breaches in history. Poor Yahoo, they really had it tough. But it's not only them. Microsoft, Facebook, Twitter, Marriott, also even if you know Marina Bay Sands in Singapore, they also got compromised, unfortunately. But there's a lot of organizations, and also the biggest one, by the way. We're not talking about the couple of 100,000 or couple of millions. Now, when you look at all of those breaches, and when you look at every successful breach within the history of internet and cybersecurity, there's two common threads that actually valid for everyone. First of all, every single breach was preventable on a technology level. The reason why those breaches are successful, it is because the technology that could have prevented existed. It just wasn't implemented correctly, or if it was implemented, wasn't operated correctly, or was absent completely. That's one. The other common trend across all of these successful breaches that every single one of them involved a lateral movement on the network, which means that the organizations that have been compromised had visibility gaps. So the hackers were able to move within the network without the organizations knowing that this thing is happening. So this is why east-west visibility is very, very important. Now, this is an actual case. This is actually one of my engineers did it in out of our Singapore lab. That is an attack simulation. By the way, it was attack simulation. We did not hack anything. It was a control environment. And I want to bring you two things. So this is basically the north-south visibility. This is what your firewall sees, right? And this is the traffic. This is what actually have happened, right? So bottom line is this is actually could be your cloud. Now what happened is that when a successful attack happened, doesn't matter what the source is, could be phishing, could be stolen credential, could be port spoofing, could be any type of infiltration. Actually, there are many, many successful vectors to happen. If you focus, your security, your perimeter security may not be able to detect it. The reason why hackers or bad guys or threat actors are not trying to break firewalls anymore, because it's very difficult to break them. Firewall technology has been around for 40 years plus. And the only way you can break a firewall is either has been misconfigured or somebody deliberately opened it for you. But bottom line, firewall technology is solid. And we have some wonderful vendors that deliver great products to protect us. Now, what really happened is the bad guys, they're trying to get behind those protections, either by phishing, port spoofing, stolen credentials, social engineering, etc., etc. And once we simulated the attack, according to parameter firewalls, IPS, IDS, everything was normal. There was nothing really suspicious going on here. However, when you look at the actual activities within the network, there was a lot of going on. So in conclusion, monitoring network lateral traffic within the cloud or east-west visibility is fundamental. If you're not monitoring what's happening within your network from workstations to workstations, chances are you would run into problems. And of course, this type of solutions are becoming very quickly one of the core tenets of cybersecurity today, and should be part of everyone's organization's successful strategy. All right? And on that note, thank you very much. I hope that you enjoyed the session. If you have any questions, we have a small booth around. We'll be there. Thank you very much.